So, question number 72 is on the screen. Which mixture of the solutions will lead to the formation of negatively charged colloidal AgI minus solution? So, basically this question is from the surface chemistry of NCERT 12. So, what will happen when your silver nitrate, because in the option they are giving the silver nitrate and your potassium iodide. So, when your silver nitrate is react with potassium iodide, it will end up with AgI and KNO3. So, this AgI absorption, that is the negative charge colloidal, this negative charge colloidal absorption is depends on this Ki, that is your dispersion medium. Now, to understand this, we can take it a simple example. Suppose you need money from your friend. Okay. So, if your friend have money, then only they are able to give you, right. So, if dispersion medium is enough, then only the absorption will more is possible. So, here is the same case, if this dispersion medium is more, the more number of negatively charged colloid will be formed. So, if you see the question number 1, just concentrate on this and this and this. So, if you see the question number 2, sorry, the option number 2, 50 ml and 2, right, that is 50 into 2, it is gives 100 millimole, and this is the highest concentration. If you see all this, this is the highest concentration of the dispersion medium. So, as I already said, if your dispersion medium is more number of negative charge colloidal will form. So, the option 2 is the correct option of the question number 72. So, question number 73 is on your screen. So, among the following, the narrow spectrum antibiotic is. So, my doctors, so this question is directly asked from your NCERT book, that is the chemistry in everyday life from the class 12. Okay. So, the option is your option number 1, that is penicillin G. So, penicillin G is the correct answer of this question. Now, we are move on to the next question, that is question number 74. So, question number 74 is on the screen. So, an alkene A on reaction with O3 and ZnH2O gives propanol and an ethanol in equimolar ratio. Addition of HCl to alkene A gives B as the major product. So, the structure of the product B is. So, what they told you, so they give you the A, it react with O3 plus ZnH2O and it is end up with propanol plus ethanol, and this A, when I am react with HCl and we are get our product B. We have to find it out what is the structure of the product B. So, this we have to solve it out. So, to get this product B, first we have to find out the product A. So, let us start with the solution. So, I am just going to open a new slide here. So, I am giving a general form. Okay. If this is my reaction, means this is my alkene, when I am putting O3 plus ZnH2O, we are get as R double bond O plus O R double bond. So, this is the general trend how ozonolysis will follow. So, the easiest way how we can do, just you break this double bond and put oxygen here and oxygen here, and you are get the product. Similarly, if they give you this product and they ask you what is the reactant, so for that you go to the backward, means just remove these oxygens and you are end up with your reactant. So, the similar trick we are going to follow to solve this question. So, they are giving this propanol, that is double bond C and your CH3 and CH3 plus your ethanol, that is so this is your propanol propanon, sorry, this is your propanon and this is your ethanol. Now, again I already told that we do the backward direction, means just remove this oxygen and attach with this. So, what we are getting? We are end up with and this is our A product. Okay. So, this is our A. From this A we are going to find out our product B. So, as we see earlier, this is our A. Now, when this A is react with HCl, what we are going to obtain? Now, see, this bond can be break on this side or this side. First, let us consider this one. So, here I am going to put a number, that is number A and this is number B. So, now follow the number A trend. So, if I am breaking this bond, so what we are get? We are obtaining this is the product. And if I am going to follow the breaking of B, so if I am going to break according to the A, we are obtaining this is the structure, and if I am going to break through this process B, we are obtaining this is the structure. Now, if we see the carbocation formation here take place here also, because we have to consider this carbocation, because HCl if it dissociate as H plus and Cl minus, and this Cl minus is act as your nucleophile and it will go and attack on this carbocation. Now, we know the stability of carbocation is tertiary is more stable than your secondary and this is your primary. So, if you see here, this is our secondary carbocation, where this is my tertiary carbocation. So, as you see the stability, the tertiary carbocation will more stable than your secondary carbocation. So, this tertiary carbocation will give you the major product. So, if I am taking this one, again I am going to rub and I am going to consider this B, that is CH3, CH3 positive, CH minus, CH3. Now, this Cl will go and attack with this tertiary carbocation and we are obtaining our product. And this is nothing but this is the product B. So, this is the product B. So, this is nothing but this is your option number 3, which is the correct answer of question number 74. So, question number 75 is on the screen. So, what is the current electronic configuration of the central atom in the following compound based on the crystal field theory? Now, if we see this element, so this is nothing but this is your coordination compound. Okay. So, in coordination compound, this cyanide is act as a strong field ligand. Now, we know when the strong field ligand is present, the splitting is more, and when the splitting is more, the electrons doesn't have enough energy to overcome from lower energy to higher energy. As a result, rather than they go to the higher energy, they more prefer to do the pairing. So, now first find out the what is the oxidation state of iron. So, here iron is basically present is Fe2 plus. So, if you see the Fe2 plus, the oxidation state is +2. So, the electronic configuration is D6 and 4s0. Now, I am going to rub this part, and so we already know they having a 6 electrons. So, 1, 2, 3, 4, 5. So, 1, 2, 3, 4, 5 and 6, and it is going to split in the two form, that is in T2G and Eg. Why in T2G and Eg? Because this is an octahedral complex. If it is a tetrahedral complex, then this order is be reversed, means Eg will come down and T2G will be go up. In T2G 3 orbitals are present, where Eg 2 orbitals are present. So, if you see how many electrons are there? 6, 1, 2, 3, 4, 5 and 6. So, I already told that this is a strong field ligand. So, when strong field ligand is present, the splitting gap is more. When gap is more, the electron does not have enough energy to go to this higher energy, and they do this pairing. So, how it will be paired? 1, 2, 3, 4, 5 and 6. So, what we are end up? We are end up with T2G6 and Eg does not have electron. So, Eg 0. So, if you see the option number 2, that is T2G6 and Eg 0 is the correct answer of your question number 75. Next, we are going to move on to the question number 76. So, the 76 question number is on your screen. Identify the incorrect statement related to PCl5 from the following. Now, again I am tell you that when they ask you correct, incorrect, first mark it. So, they ask you the incorrect statement. Okay. So, if you see the PCl5, it is a tetragonal bipyramidal. This is the geometry. And what is the hybridization? The hybridization is sp3d. So, again I am going to rub this part, and if I am draw the structure, this is Cl, this is Cl, this is Cl and this also Cl. So, these bonds are called as equatorial and this one is called as axial, and axial bond length is approximately 240 picometer. This is approximate value, and equatorial is come approximately 200 picometer. So, if you see, the axial bone length is more, and when this axial bone length is more, it is easily breakable. So, now let us move on to the option number 1, sorry. So, in option number 1, they are saying that equatorial PCL bonds, that is angle is 120 degree, and two axial PCL bonds they make 180 degree. Now, if you consider this part, the angle between this, it is 120 degree, this is 120 degree, this also 120 degree, and this also 120 degree. So, the first option is correct. Now, again I am going to rub this part and see the second option, PCL, axial and axial, what is the bond angle? The bond angle is 180 degree. So, our second option is also a correct. Now, axial PCL bones are longer than equatorial PCL bones. I already told that axial bone length is approximately 240, where equatorial is approximately 200. So, option number 3, that is correct, this also a correct, but in the questions they ask about the incorrect. So, what is left out? Left out is PCl5 molecule is non-reactive, which is not the correct statement. Why? Because this PCl, I already told, this bond length of axial Cl is longer, and when they are longer, it is easily breakable. Again I am going to rub. So, this PCl, these are the axial bones, and this having a 240 picometer, and this is easily breakable. And when this easily breakable, this molecule is also a reactive molecule. Now, I am giving a simple reaction. When PCl5 is heated, it is giving a PCl3 and Cl2 as your gas. So, this reaction is also given in your NCERT booklet. So, this fourth statement is incorrect. PCl5 is non-reactive. So, option number 4 is the correct answer of question number 76. So, question number 77 is given onto your screen, which will make the basic buffer. Now, if you see in the equations, you have to get lots of numerical data. So, no need to go to the solution to solve each and every options. Just remember one concept, that is your basic buffer it consists of two things. One is your weak base and another one is your salt with strong acid. So, it is just kind of a trick, or you can remember it is a kind of a concept. So, just forget about these numerical values. Okay. So, no need to remember this numerical value, directly concentrate on these chemical formulas. So, here if you see NaOH, and we know NaOH is the strong base. And I already mentioned, for a basic buffer what we required? We required a weak base. So, option 1 we can neglect it out. Now, if you see the option number 2, here also the strong base is given. Again, strong base we are not required. So, option 2 we can neglect it out. Now, if you see here HCl is given and ammonium hydroxide. So, ammonium hydroxide is our weak base. So, first criteria is satisfied. Now, if you see the strong with strong acid or not. Now, when this HCl is react with ammonium hydroxide, it produces ammonium chloride and H2O. So, this ammonium chloride is nothing but this is your salt with strong acid, means our basic buffer is option 3. Now, if you see onto the option 4 also, HCl and NaOH. NaOH is your strong base, and when strong base is present, this is not a basic buffer. So, option 4 is neglected. So, we have to end up with the answer option 3 is the correct answer of question number 77. Next, we are move on to the question number 78. So, question number 78 is on the screen. The major product of the following reaction is. So, this reaction is taken from the carboxylic chapter of class 12, and exactly the same reaction is given in the page number 383. So, let us start with the reaction. Now, when this compound is react with NH3, it gives the ammonium salt of phthalate. So, what is the structure? The structure is simpler, that is this. Now, when this one is heated, 2 molecules of water molecule is released, and we are get our next product, that is our phthalamide. Now, after this phthalamide, if I am removing the NH3, we are obtained phthalimide. So, this is the product, and if you see, the option number 2 is the correct option of this question. So, option number 2 is the correct option of the question number 78.